Back again with the quadratic formula. This is something you already know. Right? The quadratic formula is very familiar to you. Probably studied this in your freshman year, or maybe even before you got here. So we can solve quadratic equations using the quadratic formula. The other way we learned in our last lesson, or the lesson before that, was we could solve any quadratic equation by using the technique of completing the square. You're going to see in this lesson where those two are related to one another. The other thing for this lesson is to find approximate values for solutions, and of course that's as opposed to finding the exact values. I'm going to warm up with solving a couple equations. X squared equals 7 divided by 3. So x is equal to plus or minus the square root of 7 divided by 3. We expect to have two answers because our highest power was 2. This is the fundamental theorem of algebra. So if you find you don't have two answers, you should be suspicious. I think I might have forgotten something. Yes, indeed. Now on this one, we were able to do it this simply because we had no linear term. Down here, we have a linear term. It's a little more complicated. It will not factor, but we can solve it by completing the square. X squared plus 6x, and my first thing I'm going to do is get this out of the way. So I'm going to add 1 to both sides. I want to convert this into a perfect square trinomial, and I can do that by taking half of 6 and squaring that. So we're going to add 9, and as soon as I add this 9, I've thrown my equation out of balance. To get it back in balance, I have to add it to the other side as well. Now I'm back in good shape again. This can be converted. That's why we like them so much. Any perfect square trinomial can be converted into a binomial squared. That's actually the whole idea behind completing the square. I took the square root of x, I took the square root of 9, and I got my sign from the middle term. That's all equal to 10. I'm going to take the square root of both sides. As long as I do the same thing to both sides, I'm good. And when I do that, I remember to do plus or minus. The power of 2 and the square of 2, those are opposite operations. They cancel each other out, leaving us with what's inside the parentheses. I subtract 3 from both sides, and I have my two solutions. I expect to have two solutions, right? My highest power was 2. I should have two solutions. Minus 3 plus or minus the square root of 10. There we are. So that's just to do a little reminder of where we have been recently. Now I'm going to show you how you could develop the quadratic formula. Say you forget it and you really want it. You could develop it as we're about to do here. Now I'm going to, like I usually do, move this constant, the c, over here by subtracting it from both sides. That will leave just my leading coefficient and the coefficient that goes with my linear term. Now I do have a problem, don't I? Because look at this. I have an A here. Oof. That's my leading coefficient. What would I do? I would factor it out. Now you're probably saying, wait a second, Mrs. Turner. You're factoring out an A when you do not have an A in your second term. That's true. But here's what I can do. I'll divide that by A. And then let's check. The way I could check always, if I can distribute and get back to where I started, I know I didn't violate any rules. A times A squared gives me this, and A times B over AX gives me this, doesn't it? So that's an acceptable way to do it. I want to divide both sides now by A. X squared plus BAX equals negative C over A. Okay? Okay, now I'm ready to look at this and figure out what I have to add here. And I'm going to add something here, and that same thing will get added here. Well, I have to take half of this, so that would be half of it, and then square it. So that's B squared over 4A squared, isn't it? So we're going to add B squared. Oh. Huh. Wait a second there. Something funny happened. Whoops. Okay, I'm going to get out my eraser here and erase this. No. So I erased more than I wanted to. So give me a moment to recover. This was what? It was going to be B squared over 4A squared. And this, I have to add the same thing to the other side, B squared over 4A squared. So I do have a perfect square trinomial now, and as we know, that can always be written as a binomial squared. On this side, I have, if I want a common denominator here, I'm going to have to multiply this piece. Let me get this closed in here. I'm going to have to multiply this piece by 4A, aren't I? 4A. See if I can squeeze it in. That look okay? So I would have a negative 4AC plus B squared all over 4A squared. Over here I've got the square root of x, the square root of this, which I know it's right here, b over 2a. I take my sign from the middle. Very nice. Take the square root of both sides. On this side, of course, I'm going to do plus or minus. So I end up with x plus b over 2a equals plus or minus I'm going to do the numerator and denominator separate. And I'm going to change the order here. B squared minus 4AC. Boy, doesn't that look familiar. That's exactly what we expect to have, right? That's our discriminant that we learned about years ago. And here I've got the square root of 4A squared. So I'm going to subtract B. Let me see if I can get myself a little more space. I'm going to subtract B over 2A. And that's going to be plus or minus square root of B squared minus 4AC. Yeah, that's supposed to be a minus sign. All over, well, what is the square root of 4A squared? It's 2A, isn't it? So, voila! We have the quadratic formula. X equals, we have the same denominator, right? So we can say minus B plus or minus the square root of our discriminant, B squared minus 4AC all over 2A. Woo! So, did that take too long? I guess you wouldn't want to be doing that every time you wanted to solve an equation. It might be easier simply to memorize the quadratic equation, the quadratic formula, I mean. So let me check that against what we had up here. Yep. Minus B plus or minus the square root of the discriminant divided by 2A. Minus B plus or minus the square root of the discriminant divided by 2A. I just wanted to prove to you that completing the square and using the quadratic formula are pretty much the same thing, aren't they? One of the requirements for using this is you have to have your equation in standard form equal to 0. Only then can you go ahead and use the quadratic. In this case, your A is equal to 5. Your B is equal to 3. C is equal to 1. So we would just go ahead and plug those numbers in if we wanted to solve this. If B squared is equal to 4AC, how many solutions will the quadratic formula give you? Well, to get 2, you have to have something other than 0 here. With 0 plus or minus 0, you're only going to have one solution. So what would that mean for us if we had B squared minus 4AC, and these were exactly equal to each other? That would mean that we are talking about and if it's plus or minus 0, how many solutions are we going to find? One solution. Oh, this is something to think about. Why is it unnecessary to state that A does not equal 0 when we talk about the quadratic formula? And notice it. It's in the denominator, and all of you remember that never, ever, ever do we let the denominator go to 0. So you'd almost think we should be saying A must not be 0. Why is that unnecessary here? Oh no, I fell for my own trick. Wait a second. Stop the presses. this wasn't in standard form. Standard form is 3x squared plus 5x plus 1 equals 0. I know you were trying to tell me that. Oh, I'm so sorry. I'm not a good listener from this distance. So my A is 3. My B is 5. And my C is 1. Okay, did I redeem myself? Wow, that was a close call. I didn't even notice that my squared term wasn't the first one. That makes a huge difference. Okay, getting back to this one. Why is it unnecessary to state that A cannot equal 0? Because without our A, let's look at it right here. If that were 0, would we have a quadratic? No, it would just be 5x plus 1. Okay, so the reason it's unnecessary is that if, we can write it out, if A equals 0, comma, the equation is linear. It is not quadratic. We'd never need the quadratic formula unless we had a quadratic equation. Okay, let's try solving these, and we will use the quadratic formula. Well, I won't be caught again doing that stupid thing I did on the previous slide. This is in standard form, so my A is equal to 5, my B is equal to 6, and my C is equal to 1. All of those are positive. So let's always look at the discriminant first. I always figure the discriminant first. So B squared minus 4AC. B squared would be 36. A times C will give me 5 times a negative 4. So it's going to be positive 16. X is equal to minus whatever our B is. In this case it was positive, so minus 6 plus or minus the square root of 16, that's going to work out nicely, all over 2 times A, which is 10. So our X is equal to a negative 6 plus or minus 4 divided by 10. So we've got, let's do it this way. Either X is, make it look like an X, minus 6 plus 4, which would be a minus 2 over 10. That would be minus 1/5. That would be one solution. X equals minus 1/5. Or X is equal to, both of these are negative, and it would be a negative 10 over 10. X equal to negative 1. Those are the two solutions we'd have for that one. So let's go down and look at this next one. My A is equal to 5, just like the last time. My B 6, my c. Now these were in the proper order, right? X to the second power, x to the first power, x to the 0 power. My discriminant, b squared minus, minus 4ac is equal to what? 36 again. A times c is 10, so minus 40. My discriminant is equal to negative 4. So now when maybe I could move this up a little bit so you can see the quadratic formula. My x is going to be equal to minus 6 plus or minus the square root of negative 4 all over 2 times a, which is 10. Now a year ago, or a couple years ago, when you found that the discriminant was less than 0, what would you say? You'd say, no real number solutions. True. However, now we know what to do with that. We don't need to restrict ourselves just to real numbers. Ordinarily we do, but one of the things you're learning right now is how to cope with a negative under the radical. So I factored out the negative 1, which is the same as, the square root of negative 1 is the same as I, and then this would be a 4 all over 10. So that would be equal to negative 6 plus or minus 2i, wouldn't it? The square root of 4 is 2. This could be reduced. We have a factor of 2. I can factor out here and out of here too, so I would have a negative 3 plus or minus I all over 5. And that would be my answer. So I've got 2 answers, which I expect when I have a square root. Oh, that's the end. That's as far as we're going. 23 minutes. This is more like it. See you in class.